Okay, so let's do a slightly more complicated example. And we're going to solve the same problem in two different ways, just so we have an example of integrating in the x direction with it split, and then another example of integrating in the y direction, which we haven't done yet. All right, so the functions that are bounding our region in this case are y equals the square root of x plus 1, and that's just the regular square root of x function moved up to 1 on the y value. And then this is a sort of a weird function, y equals square root of 2 minus x plus 1. But all we've really done is we flipped the square root over, scooted it over to 2, and then also shifted it up 1. And then the lower bound is y equals 1, so it's this constant value, which is the horizontal line, y equals 1. So the region we're talking about is this one. And so what we're going to do is, in the first case, we're going to go in the x direction, which is the way we've been doing it. So we need to think about what is playing the role of the ceiling and what's playing the role of the floor. And we have a little different scenario here, because between here and here, the ceiling's been played by this function. But as we go over here, that ceiling changes and now is being played by this function. So we're going to have to use two integrals. And it's going to split here, right? And we could, since we're not given it, we would have to find out what the x value of this point is, but you can also guess it might be 1, since these seem pretty symmetric, and it is. If you plug in 1 for this, I get the square root of 1 plus 1 is 2. If I plug in 1 for here, it's 2 minus 1 is 1, and the square root of that is 1 plus 1 is 2. So this point here has an x value of 1 and then a y value of 2, which will be important in the next example. Okay, so let's compute this. We're going to have to compute actually two integrals. In the first integral, we're going to go from 0 to 1 on the x-axis. And then, so for this integral, our floor is y equals 1, and our ceiling is the square root of x plus 1. So here's our first function, square root of x plus 1. And then our second function is constant, so it's just 1 dx, and that's the first part. And then we're going to go from 1 to 2. And then our ceiling in this case is the square root of 2 minus x plus 1. And then we're subtracting off the floor, which is still 1. So let's do this. We can simplify this a little bit first. We have the square root of x plus 1 minus 1, so this is just becomes the square root of x. And then we're adding from 1 to 2, the same kind of thing happens, the plus 1 minus 1, 2 minus x dx. So now we have two integrals to take. The first one is just, this is x to the 1/2, so we can just go ahead and take this. We're going from 0 to 1. We're adding 1, so this is to the 3/2, and then we get a 2/3 out front, and we're going 0 to 1. Okay, and then over here, we're actually going to have to use substitution. So let's do that. We'll say u equals 2 minus x. Then du is negative dx. And so when I make this substitution, I really have the square root of u, and this is minus du. And my new bounds are, well, 2 minus 1 is 1, and 2 minus 2 is 0. So now my lower bound is 0, my upper bound is 1. And so this gives me minus the integral square root of u, 1 to 0, which seems weird. Let me just rewrite all this since I messed it up so bad. So minus the integral 1 to 0, square root of u du. And I'm going to use that rule that you might remember from the beginning of our chapter on integrals, which is if I flip the bounds, I can change the sign, and so this really becomes positive 0 to 1 square root of u du. And I'll just keep sort of dragging this one along so that we can finish it all at the same point. Okay, so I'm going to take all of this over here, and maybe I'll wait to plug these numbers in until I take this integral. So the integral of this is going to be u to the 3/2 and then 2/3 out front, but it's still 0 to 1. And so notice that these two integrals are exactly the same, which you might guess because these two areas look like they're pretty symmetric. So let's finish this off. I'll do 2/3 1 to the 3/2 minus 2/3 times 0 to the 3/2 for this, and then the purple one will give me 2/3 1 to the 3/2 minus 2/3 0 to the 3/2. And so my answer is going to be, so I get 2/3 because 1 to the 3/2 power is just 1, and then minus this all gives me 0, and then this becomes plus, this will be 2/3 again, minus 0, and so the whole thing, sorry, it's just 4/3.